Welcome to This Is My Architecture. My name is Usman, and I'm here today with Dan from Evertz. So Dan, tell me a little bit about what Evertz does.
Right, so Evertz is a broadcast equipment manufacturer, and some of the products that are getting a lot of press recently are our media asset management, automation, and cloud playout solution.
So I hear you say broadcast. Can you talk about the difference between broadcast and streaming on mobile devices, for example?
Right, so a broadcast stream, for example, is your linear playout channel that you would get as your regular cable channel that you would actually receive at home on your television and things like that.
So what does Overture do and what does Mediator do? Those are your specific products here.
Right, so Mediator is our media asset management and automation solution, and Overture is actually that entity that generates your linear channel of TV for distribution via a bunch of different methodologies.
So how does this whole workflow start? Where does it start, and how it flows through?
Sure. So typically in a broadcast facility, there's a scheduling and traffic piece of software that basically says, what piece of content do I want to play at one particular time? And that traffic schedule, basically being an XML file quite often, comes into a Mediator. Mediator receives that file, looks at it, parses it, and says, oh, I need this particular piece of content to actually play out. So that would initiate a bunch of different things. For example, if that content is in Glacier, Mediator would move that content to S3, and then it would move that content to an EBS volume, for example, connected to the Overture box itself. So that would be an EBS connected to a particular EC2 instance.
And so the content then lives inside the cloud, I assume, in that case. Where is the content originally coming from? Is it pre-recorded files? Is it live channels? What is it?
Right, in terms of the file flow, those are mezzanine level assets that are stored up in the cloud, and that could come from on-prem into an S3 type bucket, or it could be natively delivered into the cloud for the particular broadcaster. So there's a file flow 100%, but there's also a live element to the whole solution as well, where a live signal could come into the Overture in addition to the files, and then you can mix between file and live and then stream back out.
So you mentioned broadcaster. Is there any broadcaster today that's actually using this solution?
Yep. Our premier customer in this particular space with these products is actually Discovery Communications. And probably about a year and a half ago, they made a decision they wanted to go and move their complete infrastructure up into the cloud. They looked for partners in that whole area. AWS was one of them, and we were the other one to help them move that on-prem footprint all up into the cloud.
And what's the scale of that implementation today? And is it in production?
It's in production, and basically just last month, Discovery made the public announcement that their complete domestic US linear channels have migrated from on-prem to the cloud. So that's a huge thing for them. It's probably about 50% of their US revenue and a third of their global worldwide revenue.
So let's get back a little bit to the architecture here. So you talked about scheduling and how the files are moving into Overture. Is there any specific EC2 instance types that you have to keep into mind, or you had to go through with respect to the architecture, with respect to Overture or Mediator?
Sure. Based on the complexity of things that the Overture has to do from a video file perspective, from an audio file perspective, but also from a graphics perspective, these Overtures have been placed on a G2 or a G3 instance. So utilizing a GPU is really, really key to the stuff that the Overture does in terms of the complexity, especially on the branding side of things. So a G3 instance is used across the board for the Overtures.
So it's basically for rendering, real-time rendering of these overlays on top of your screen.
Correct.
And so is there any specific graphic commands that the GPU is being used for, or is it purely from a performance perspective?
It's from a performance perspective, but we also use, it's an NVIDIA-based, CUDA-based implementation, but the big thing is offloading those very computationally complex and heavy things from CPU to GPU, because there's a lot of other things that the CPU has to do along with just the graphics and overlay rendering.
So I see the implementation across 3 different availability zones. In the case of broadcast, obviously, the high uptime is a requirement. In this particular scenario, how do you achieve that high uptime with respect to broadcast?
So yeah, uptime is paramount for any broadcast application. So we looked at the architecture and we said, you know what, the right thing to do is actually split the Overture instances, which is the Playout engine, or the Mediator instance, which is the database and the automation and the schedule, across 3 different availability zones to get that resilience and reliability. So Mediator runs a MariaDB database, that cluster is spread across all 3 availability zones. So you could actually have a failure, but not impact the actual final operation of the system.
So what kind of stream is emitted out of the Overture?
Right. So coming out of the Overture is a mezzanine level compressed stream. So that would, let's say, be a 50 megabits type signal coming out at H.264 as one particular choice. And actually, it's interesting, that particular thing, again, for resilience and redundancy perspective, actually is sent to 2 10 gig direct connects. So we can actually say, you know what, if there's a failure in my colo facility for my 10 gig direct connect, I could still get a main or redundant stream to my final satellite uplink and emission encoder.
Then from the direct connect then goes to the satellite uplink. So these are 2 live feeds that are going out. How do you do the switching?
Right, so these feeds come in and there is actually an automatic clean switch, which buffers and aligns 2 particular signals and looks for which one actually should go to air. And that automatic clean switch will fail from one to the other as appropriate, and that will actually feed the satellite uplink.
Given this is in the cloud, right, are you guys doing anything with respect to the automation as well of the whole thing?
Right, so in terms of the whole infrastructure that we're talking about here, this is stood up in one particular region. We are also standing it up from a redundancy perspective in a separate region as well. So we use CloudFormation templates across the board to actually stand up the Mediator instances, stand up the Overture instances, and then replicate that into a separate region as well.
All right, and so that is all automated via CloudFormation or some other mechanism?
Yep, all CloudFormation templates.
All right, and so the switching happens here, and then is there any kind of compression that's being introduced at that level to go up the satellite, or is it basically 50 megabits coming out and then going up?
Yep, so there's a final box here right after the clean switch, which is your final emission encoder, which will bring the signal back down to even a lower bit rate before final satellite uplink.
Okay, and why aren't you implementing any of these things in the cloud, or have you thought about doing that in the cloud?
It's interesting, and that's where the industry is kind of going. I think right now, a satellite uplink is a hard piece of infrastructure that you can actually virtualize. So your final uplink to the satellite is actually has to be on-prem. So that's why some of the equipment is still on-prem. But if you look at it for 5 years from now, 10 years from now, and it'll be a long tail on this particular one, but how could actually I define an IP-based meet-me for a digital stream coming out of the Overture and have people pick it up directly from the cloud and avoid the cost and complexity of a satellite and a satellite transponder.
Very cool. Thanks, Dan, for the time. Very interesting. Thank you for watching This Is My Architecture.